Hi everybody, this is Kevin from Map Practical. Today I'm going to be going over this map. We're going to be doing a fairly involved timber analysis at the Lubricht Experimental Forest here in Montana. And this is in ArcGIS Desktop. Let me bring over the Word doc that's the instructions. This will be posted down lower in the, let's see if we can get this right, down lower in the comments. So the bigger picture on this is we're trying to remove from a large selection of stands out in the forest, stands for harvest that are between the ages of 70 and 125 years old. And then the stands can't be adjacent to young stands that are between 1 and 20, so we don't want to do any of the new growth. The stands can't be within 250 meters of old growth. So if the trees are from 150 to 200 plus years old, then we don't want to cut those stands. We also have some science going on out there, so there's monitoring plots, and we don't want to cut into somebody's long-term experiment, so we can't use those plots. The stands have to be on land that is ranging from 0 to 15% slope, because we don't want to do any high-angle logging. And the stands need to be within 100 meters of a road, because it's going to make it easier for us to extract the trees. And we don't want to be within 20 meters of a stream, because we want to protect the riparian area. Okay, so that's kind of the bigger picture of where we're coming from. So, and there's the map of where we're headed when we're all done. Okay, so let's get our catalog rocking here. So in our catalog, I've got an intro GIS folder here, lab 9, and then some raw data, and it's always a good idea to take a look at your raw data. So we've got a boundary, and that's the boundary of the entire property. We've got the forest stands, so those are all the individual stands within the forest, the perennial streams, and also the road classes. And I always like to look at the properties and just see how they're shaping up. So this one's in NAD 83, UTM Zone 12, and my forest stands are in Zone 12 as well. And my perennials, I know though, have a problem. So they have an unknown coordinate system, and we're going to need to fix that. We'll come back to that in a second. Let's take a road classes and see if they're looking okay. So the roads are also in UTM Zone 12. And then we've got a couple of tables. So the forest inventory table is actually all the data we need for the lab. And then the sample point layer is the science projects that are going on out there. All right, so back to perennial. We already looked at its properties, right? It's got an unknown coordinate system. However, if we look at description up here, that's the metadata. So the properties tell us what the actual layer is in. The metadata tell us what we think it should be in, or what it thinks it should be in. I'm not going to update right now. I'm just going to scroll down and take a look at my spatial reference. So this one should also be in NAD 83 UTM Zone 12. So we're going to have to fix that. So I'm going to get my search bar here, and I'm going to type in define, because I'm looking for the define projection tool. There we go. So we're going to go with the data management tool. My mouse keeps going lost. Here we go. Take a sip of tea while that works up. So then perennials will go in there, and that's our perennial streams, the unknown coordinate system. And we could go through here and dig through the folders and find it. It's not too hard, but we can also import. So from this drop down here, we can say import, and then I'm going to look back actually to the folder for this. Let's see here, Intro GIS, Lab 9, and there we go. And so the boundary we know had the right coordinate system, and see there you go, it imported the NAD 83 UTM Zone 12. You could have also just dug through projected coordinate systems, UTM, NAD 83, right, and found Zone 12. All right, and we'll let that tool run. It goes pretty fast. And we'll just check it, make sure it's been fixed. So there we go. Now the coordinate system is set for that layer. And now in the Lab 9 folder, I'm going to make a new file geodatabase. And I'm going to name this one my last name, McManigal, _ Lab 9. Oh, Lab 2. Nope, we want Lab 9. There we go. It'd be helpful if I could spell my own name. Oh, let's rename it. There we go. And then inside of that, we're going to make a new feature data set. and this is going to be Lubrecht, oops, underscore data. And you can call it whatever you want as long as you have it figured out. We are going to set a full coordinate system in this one because this analysis kind of requires the data to be fully projected. So we're going to go with NAD83, UTM, Zone 12. Usually I like to go with just a coordinate system like NAD83 or NAD27, but we're going to do the full projected coordinate system. And there's no vertical coordinates in this data, and we'll finish. And there we go. And so now we just want to import feature class multiple. And we're going to open up Lab 9 and drag our layers in there. Okay, and say all right. And that'll take a second to run, probably not too long. All right, that's successful. Very good. Close that. And now we can take a look inside our geodatabase and our feature data set, and it looks like all the layers are there. Excellent. And the last thing we need to do is import those two tables. So I'm going to right click on the geodatabase. It won't let you put them in the feature data set, so definitely do it on the geodatabase. Import tables multiple, and then back in the raw data I'm going to grab the forest inventory and the sample points and put those in there just like that. Excellent. Okay, we got it all figured out. Both the tables are in there. Great, we're done with the raw data. So let's go ahead and open up a new ArcMap document. While ArcMap opens, I'm just checking with my instructions, make sure I've got everything set up properly. And I'm just going to open a blank template and bring ArcMap over onto the screen that I'm sharing. Okay, and actually while I'm here, I'm done with our catalog, so I'm just going to turn it off so I don't get schema locks. And here we go. Okay, it's always good to go to File, Map Document Properties, and set the geodatabase for this lab. So there we are for Lab 9 geodatabase. And store relative path names. That means it's just looking for the data in the same folder that the MXD is in. Great. And now I can go into add data, and I can see the little house on my geodatabase because that's the home one, and I'm just going to add everything. Very good. All right. These two layers over here that are the tables, we don't need those right now. So instead of being here in the list by source, I'm going to go list by draw order. So it just hides those, gets them out of the way. And now I can move some things around. So I'm going to put my boundary underneath, got my forest stands. And it's a little bit messy right now, but we're going to clean it up. I'm going to right click, go to zoom to the boundary. There we go. Okay, zoom out a little bit so we can see all the stands. The first thing that I have you guys do inside of here is to clip the data, but just in the data frame properties. Don't actually use the clipping tool. So let's go over to layers, and then we'll go to the data frame, and then down here under clipping options, we're going to say clip to shape, and then we're going to specify the shape, and it's going to be the outline of the boundary. All right, we definitely don't want to clip it to streams or anything like that. And then I like to exclude the layer that I'm clipping so it doesn't clip itself, so the boundary will still show up. And then I'll say OK, and there we go. So now it's a little bit cleaner. And I'll zoom to there. There we go. All right, so that's what we're working with today. It's going to get better. We're going to clean it up a little bit. How about I make the streams, I'll put them under the roads, give the streams a color that is blue because it's water. Great. And then the roads, we'll just make those a thin black line. All right, there we go. And then it's always a good idea to save. So this is going to be Lab 9, and it'll automatically throw an MXD on it, saving it to the right folder. Great, looking good. Okay, let's take a look. All right, so the next thing that we have to do is we have to make an area field for the forest stands. So I'm going to open up the attribute table, and you can right click and go open, right? Or you can hold down the control and double click the layer. and there's not an area field now, so I'm going to go to the drop down and ask it to add a field, and then I'm going to name this area and change it to a double. Great, and then we're just going to calculate the geometry on it. So calculate geometry, and what we're looking for is acres. We don't want to use areas, we want to use acres, US acres. Great, okay, and if we take a look at the statistics on that, the total acres for all those forest stands is 43,609 acres. And you want to make a copy of that because that's going to be an answer to the first question. So the first question asks how many stands are here, and that's the number of rows. So there's 1,998, and then there's the acres that we just calculated. Okay, you can paste that right in and close this up. Okay, so you might have also noticed that inside that forest stands there's not that much data, and that's because we need to join that forest inventory table. So we're going to go to Joins and Relates, Join, and then choose the forestry inventory table. And then the one thing that is a match in both of these is this attribute called slink, slink 2000. Okay, so there's an slink 2000 in the forest inventory table, and there's an slink 2000 also in the forest stands. You could validate the join, it'll run for a while, but it'll probably tell you that there's a couple of attributes that don't have the same type. That's okay, we're just going to run it. And then the way to check if it worked, obviously, is to open the attribute table. And now you see that there's a lot more data in here. So if we scroll over, we've got all the things that we need to do our analysis. Okay? All right. So that join is not permanent right now, though, so we're going to make it permanent by right-clicking and going down to Data, Export Data, and navigate to our Lab 9 geodatabase. So there we are in our Lubrecht data, and we're going to call this one cut blocks, because this is the layer that we're going to be working with throughout the lab. I recommend you call it cut blocks because then the instructions will make sense. So save and OK, and it'll ask if we want to add it. Yes, we do. Okay, so now we've got another copy. We got the forest stands and the cut blocks, and we're ready to go. I'm going to save. It's always a good idea to save. And let me just check my instructions. Okay, so what I'm going to do is I'm going to make forest stands multiple different colors so you can see what it looks like. So we're going to go into its symbology tab, and right now it's just a single symbol. We're going to go to categories, or actually let's just go to quantities, and graduated colors, great. I'm going to do BFBA, and BFBA is board feet per basal area, all right? And so now it's going to classify this thing in different colors of green. You'll see what it looks like here on screen, okay? And then I'm going to turn the cut blocks back on over the top of it and go into its symbology. We're going to leave it a single symbol so that as they start to get removed, they go away and it's easy to see them. And then we're going to go to the selection tab here, and we're going to go with this symbol. The normal selection color is this blue, but we wanted this one to stand out, so I'm going to make it red. And you won't see anything at first, but once we start making selections, it'll really change. Okay, and then on the display tab, I'm going to make this thing about 30% transparent, and then you'll be able to see the forest stands underneath it. Okay, so now we're all set up. Let me just check the instructions, make sure I've got everything going good. Okay. So the first question we already answered, right? There's 1,998 stands, or excuse me, cut blocks, and there are 43,609 acres. Okay, and then we're going to go ahead and do a quick query builder under cut blocks. We're going to do a definition query here. We only do one in this whole lab, so we're going to build it. I'm going to go inside the query builder, and you could just type it in, but what we're looking for is owner equals, and then I'm going to get the unique values, and 1, and inside the lab it lets you know that 1 stands for is the University of Montana, so it's owned by the University of Montana, and we don't want to cut any land that we don't own, so this is important. So when we hit OK, you'll see that we did lose some of these cut blocks, right? So now if I open up the attribute table, we can take a look, and so now we're down to 1,093 cut blocks, all right? And that's the answer to number 2, and then we can check the area by looking at the statistics, and now we're down to 19,994 and some change. And that's the number of acres after we've done that definition query. Okay? All right. So now we're going to start making a bunch of selections. And it's important that we do this in a systematic way, because we're going to be making selections from currently selected values. And if we make a mistake, you'd have to go all the way back to the beginning. I'm going to show you how to set yourself up with intermediate steps so that you can recover from a mistake and you don't have to go all the way back to the very, very beginning. Okay? All right. So let's start by opening the attribute table for cut blocks. And there's a number of ways you can get to this. We're going to do it through the table. Under the drop down here, we're going to select by attributes. And in this particular case, we're looking for stand age. So the first one is that we're going to only harvest trees that are between 70 years old and 125 years old. Okay? So if we go down to about the midway here, there it is. So there's stand age, and we could do an equals, get unique values, and you can see in here that there's coded values, but they don't go up between 75 and 125 years old, or 70 and 125. And that's because they're coded values. So in order to know what those codes stand for, we have to go back to the raw data folder. So let me do that now and open up the forest inventory PDF. So I'll open that PDF and then I'll bring it over. So here's the forest inventory PDF. And if I was to do Control F, it'll bring up this little search tool here, and I'm just going to type in stand age and hit enter. And there we go. So it went down to the stand age attribute, and these are coded values. So we're looking for the code for from 70 years old up to 125. So we need, what do we need? We need 8, 9, 10, and 11. And that's where you find that information. So metadata is really important when you're working in GIS. Okay, so now we're back here on stand age, and we know that we're going to need numbers 8 through 11. We could do stand age equals 8, and then you would have to do or stand age equals 9, right? And you can't use and, because then it would be looking for both 8 and 9 inside the attribute table, and that doesn't exist inside of one row. It's one or the other. That's why you have to use or. But this is complex, and there's a faster way to do this. So I'm just going to clear it. And what if we did stand age in, and then gave it the parentheses, and then we can do 8, and then put a comma in between each one. 9, comma, 10, and then 11. We got to get a comma, and then 11. Right? And then we can verify it and see if it likes it. Yes, it was verified. So cool. And we're going to hit apply. Great. All right, so this made a selection out of the currently unselected values on screen, and now we have 467 out of the 1093 selected. So I'm going to go to just those. And what we can do is keep this attribute table open for quite some time and just make all of our selections and keep seeing the data. So I'll just tuck it over here. Okay, so and that was the answer to number 3. So in number 3, there's 467 cut blocks selected. Okay. All right. Now we're going to do this long selection process, and we're going to have to keep making selections from this selection. So we don't make any mistakes. We want to have an intermediate step. So now that I've got this first selection, I'm going to right-click on my cut blocks, go down to Data, Export Data, and this is going to make a totally new layer. I'm going to put it inside of my feature data set and call it cut blocks 3, because it was the answer to number 3. I'll say save and OK. And it'll ask me if I want to add it. Yep. And so now I'm just going to turn it off and leave it there in reserve in case I make a mistake. Okay? All right. Okay, so now what we're going to do is compare these currently selected features to another selection we're going to make inside of forest stands. So I'm going to open up the forest stands attribute table by double-clicking on it and holding down Control. Right? Or I could have right-clicked and said Open Attribute Table. But now we have both of them open down here. So here's the forest stands, and here's the cut blocks. The forest stands is still that joined table, right, that has all of the layers from the forest inventory table. So in forest stands, we're going to go to Select by Attributes, and now we're looking for the younger trees. right? So we're trying to get rid of all the trees that are from 0 to 20 years old, basically. And you can see that this is a join table because it has forest stands dot and the rest, right? So we got to get down to stand age. So stand age in parentheses, get unique values. And we could go back and look at the metadata if we weren't sure, but for the young trees, it's going to be 1 and then comma 2. And we'll verify it. Yep, likes it, and we'll hit OK, apply. Great, and then we can close that. And so forest stands, we've got 53 selected. That's the right number. There's no question for that inside the lab, but that's the right number. And now we're going to compare it, these little selections, to the selections that we have in the cut blocks. So we're going to use a spatial location selection. So from the drop down up here in the menu, we're going to go selection, select by location. I'll pull this tool over here. So we need to tell it to remove from the currently selected features, and we're working in cut blocks. We're still working in our original cut blocks. We're going to tell it to compare it to forest stands, yes, and we want it to use the selected features in forest stands. And in this case, we don't want the cut blocks that we're going to harvest to touch the boundary of any of these young tree cut blocks. So touch the boundary of the source here, right there. And then there is no search distance on that one. Okay, once we have all that set, we can hit apply. And then if we check over in cut blocks here, we can see that that's the correct number. 435 of those cut blocks are selected. So we'll say okay. Okay. So the answer then for number 4 is there are now 435 stands selected in cut blocks. And how many was removed? Well, we had 467 before, so you can do the math and figure out how many were removed. We definitely want to right-click on cut blocks, go down to Data, Export Data, and go inside of our feature data set. And this one, because it's the answer to number 4, is going to be cut blocks 4. Okay. Say OK. Yes, we want to add it. And again, this is just a backup in case we make a mistake. All right. So next, we're going to apply another query or another selection to forest stands. So we'll go back to forest stands here. We'll go up into the attribute table. We're going to clear the old one. And now we're after the older trees, right? So if we took a look at the metadata, let me see if I can open that up again. Where did it go? Okay, there we go. So there's that. And we're looking for the oldest trees that are going to be between 150 years old and greater than 200 years old. So that's going to be code 13 and 14. So we're going to do this selection of stand age in parentheses and scroll down, and that's going to be 13 for a coded value and 14. So those are our old growth trees. Apply that. Great. So that's 319 selected out of those. And now we're going to do that select by location again on cut blocks. So out of our 435, we're going to go to selection by location. And we are still working with our original cut blocks. We're still looking to remove from the currently selected features. We're still comparing it to forest stands, but we have a lot more now, 319, right? But this time it's not going to be touch the boundary of. It's going to be within a distance. We're going to keep our distance from those guys, from the old trees. So are within a distance of the source layer, and we're going to set this to 250 meters. Okay, so now it's going to remove all those stands that are within 250 meters of old growth, and we're going to hit OK. And now our cut blocks are down to 230, and that's the right answer. So for number 6, there are 230 cut blocks left, and then we can check their acres by looking at the statistics here. And we've got 4,335 acres left. So those are the answers for number 6. And we definitely want to export it out again. So the original cut blocks, data, export data. Put it inside our feature data set. And this is the answer to number 6. Now some people will say, well, you skipped number 5, but there's another question in for number 5, and we'll get to that in 1 second. So this is cut block 6. Yes, we want to add it to the map, and we're just going to turn it off as a backup. So question number 5 asks, describe in words what the spatial query achieves in terms of the cut block selections. And I just talked about it, but basically what it did is it removed any selected stands from cut blocks that have stand ages of 150 to greater than 200 years within 250 meters of those cut blocks. Okay? So you can put it in your own words, but that's basically it. All right. So moving on. All right, we have one more thing that we need to do. There are some sample points that we have, and those represent plots on the landscape where scientists have been working in long-term studies, and we definitely don't want to cut any of their blocks. Now, technically now, though, we're done with the forest stands. So these selections that are forest stands that are green on the map right now, we don't need those anymore. So just to clean this up and make it a little bit easier is if you select the forest stands attribute table, then you could clear selections. You don't want to do it to cut blocks though, because if you do it to cut blocks, then you're going to have to go back and recover to your last correct one. So make sure you're on forest stands and then deselect. Great, and then we can actually turn this attribute table off. So we're just working with cut blocks. But now let's bring in those points. So we'll go to File, Add Data, Add XY Data. Right? And sample points is the one we want, so that's that other table in the geo database. And since we're in NAD83 UTM zone 12, you can guess what the X field is going to be, UTMX, right? And you can probably guess what the Y field is going to be, UTMY. The description of the coordinate system is perfect because it's what it was collected in, and we're going to say okay. And there we go. So now we have all these points on the map. I'm just going to change their color so they show up a little bit better. Make them like a bright orange or something. There we go. We're going to do a select by location now, right? So we're going to go down to selection by location. And this time we're still removing from the currently selected features. We're still working in our original cut blocks. We're going to change it to compare it to the sample points that we just put up, right? And this time it's going to be contain the source layer, so they're inside of it. Where is it? Contain the source layer, there we go. And we're going to uncheck apply a search distance. We don't need that. And when we hit OK, we're down to 207, and that's the right answer. So again, I'm going to right click on cut blocks and export them out. That's going to be cut blocks, yep, number 7. So that's the answer to number 7. And say OK. Yes. All right. Turn that off. Super. And now is probably a good time to save our ArcMap document. All right. So we're about halfway through. We have 207 cut blocks. I'm going to go ahead and stop the video, and we'll do a part 2 on this. If this has been helpful, great. Then please like it and subscribe, and that'll help me out. This is Kevin with Map Practical, and I'll be back with the second half of the Lubric Forest analysis in just a moment.